Welcome to qnawire.
What are the formulas related to more placid perturbation theory up to second order? So first of all, remember that our Hamiltonian is going to be equal to and the initial H0 Hamiltonian plus lambda times the perturbation. And the main assumption is that the energy 0 is going to be equal to the Hartree-Fock energy, and that my initial wave function is going to be equal to the Hartree-Fock wave function. Additionally to that, we know that for perturbation theory to work, the perturbations are going to be small in order to achieve the result. So with this, on up to second order in perturbation theory, the energy can be described as E0 plus E1 plus E2, and the wave function is going to be phi equal to phi 0 plus lambda times phi, the first order perturbed wave function, plus lambda squared times the second order perturbed wave function. So H0 acting on phi 0 is going to give us the initial energy times phi 0. H0 acting on our initial perturbed wave function plus b times the initial wave function would be equal to E0 times phi up to the first order plus energy up to first order times phi 0, and H0 times the wave function at the second order plus the potential times phi at the first order is going to be equal to E0 times the wave function at the second order plus the wave function at the first order times the wave function up to first order plus the energy up to second order times the wave function at the zero order. So all of these terms are going to correspond to lambda to the 0, lambda to the first order, and over here lambda to the second order. This is going to come from the application of the Hamiltonian times the wave function is going to be equal to the energy times my wave function. So collecting all of these terms, we're going to collect all of the zero order terms on the first one, the first order terms on the second one, and the first order terms on the second one and the second order terms on this third equation, which is going to give us the possible solutions. So over here we can always write it down as being our gets as follows. So upon application of phi 0 towards the left of all of these equations, what we're going to get the expressions for the zero order energy, which is going to be phi 0 h phi 0, for the first order energy, which is going to be phi 0 b times phi 0. So then I wrote down this over here, just out of. And finally, the second order energy, which is going to be phi 0 times the potential times phi 0. Sorry, phi of the first order here. And let me erase this guy. So with this, what we can do is write down the Hartree-Fock energy, which would be equal to directly e to the zero order plus e to the first order. This is going to be because this is equal to my Hartree-Fock wave function times the Hamiltonian plus the potential times phi 0 over here. And at the MP2 level, the correlation energy would be equal to the energy at the second order. So now what we need to do is to get the expression for this energy at the second order, which in terms of spin orbitals will be equal to minus 1/4 of the sum over AB, which are virtual, sum over ij, which are occupied orbitals, of the following expression: AB double slash ij squared, the size of this vector, divided by the energy of A plus the energy of B minus the energy of ith orbital minus the energy of the jth orbital. So if you are not familiar with this double slash notation, essentially what this means is that this would be equal to AB ij minus AB ji. Okay?